Okay, this is not November 9th. The topic is potential energy. And this is an example of potential energy. There's a lot of classroom stuff that we did around this idea, and you're not going to get it because this is online. So I'm going to draw you a little picture right here. Anybody who's been on a roller coaster knows that this thing is about to start going really, really fast. And this is what potential energy is. It's, holy cow, this thing is monstrous. It's all about energy that's about to happen. Okay, nothing's happening yet, but this thing's about to start moving really fast. And it can do a lot of work when it's moving really fast. So it's pretty much energy in waiting. That's what potential energy is, and this is what we're going to talk about. Build on the idea of work and energy, and observe how lifting objects create the potential to do work. This should be on page 17. Okay, vocab for today. Gravitational potential energy. There's lots of types of potential energy. This is a battery, little copper top, and it's got a positive and a negative end. This is actually a special type of what's called chemical. And I'm just going to go PE from here on out. Okay, we're looking at potential energy due to gravity. When I lift something up in the air, it wants to fall, and when it does, it can do a lot of work. So it's got potential. So answer this. What does potential mean to you? Write down your own definition, share with yourself, and let's see what we end up with. So we have page 17. Okay. Potential energy is energy stored, and there should actually be a very small g here, because this is gravitational potential energy. Energy stored in a body due to gravity based on its position. And before I get into all of this, I have a picture to draw for you. Please draw this. Same mass. Which one do you think has more potential energy? I mean, they both kind of have the same height, right? The only difference is how far will an object fall before it drops? Okay, this one's going to drop a lot sooner, so it technically has less height. It's a relative height. That's kind of the point. More height, okay? So the first thing that you need to add to this is this idea. Height is relative. Okay? How much potential energy depends on how high it is to the next closest surface that can stop it. That's what relative means. It's relative to the table. The same ball has less height and less PE. Okay? This has more height and more PE. So it's relative to position. Back to our definition. Formula. Potential energy equals mass times acceleration due to gravity, which is 9.8 times height. Or PE equals mass times gravity times height. We're not going to look at this yet. Okay. Relationship advice. Directly proportional to mass and height. Okay. If height doubles, then potential energy doubles. Or if mass doubles, then potential energy doubles. They're both relative to each other. And let's try a basic problem right now. Let's use this formula. Here we go. Swimming pool, high dive. Not so high dive, but 6 meters is still pretty good. What's the potential energy of this 50 kilogram person if they're on a high dive that's 6 meters tall? Right? If they jump off, they're going to start falling and can do work when they hit the water. Well, first you put in the mass, 50, times gravitational acceleration, 9.8, times height, 6 meters, equals what? 300 times 9.8 equals a little less than 3,000, I'm guessing. Let's see, calculator tools on my phone. And wait, let's get the iPad out. Okay. 100 times 9.8, 2940. All right. That's one of your basic ideas, is can you solve for potential energy given the basics? 2,940, and the units are still joules, so this is important to note. Units for all energy equal joules. Joules are related to calories. Calories are how we get energy, but we don't use joules with food. We use calories. I don't know why, because joules per second equals watts, which is how we pay our electric bills. So we use joules for electricity, but calories for food? Not so sure why. Sorry. Okay, so this is basic. Can you do a formula? And by the way, potential energy is related to work. It's exactly the same. This is why I made you do work against gravity. When you're lifting things, how much work are you doing? Because work equals force times distance. So work against gravity equals force gravity times distance. Force gravity is mass times acceleration due to gravity times distance. Do you guys see what's happening? PE equals mass times 9.8 times height. It's the same thing. We're just calling it height instead of distance. But essentially, they're related. The amount of work you do tells you the amount of potential energy that happened. For example, on your final, there's a question like this. Okay. If it took 2,000 joules of work to lift this weight, what's the potential energy right now? It's the same. If it took 2,000 joules to lift, then it's got 2,000 joules of potential energy at the top. Okay, let's look at a proficient example. Diver, swimming pool, 10 meters, 980,000, that's many joules. What's the mass? Find the mass of this diver. Given the other two, find mass. That's your proficient. You know what? Well, that's fine. What's your proficient idea? So, I'll do one, and then you do one. 9,800 equals mass times 9.8 times 10. 9,800 equals mass times 98. And then you divide and divide. 9,800 divided 98 equals 1,000. Nope. 100 equals mass. 100 kilograms. Molto bene. Very good. That's our proficient. You do one. Let's do the same problem. Well, same scenario. 10 meters, 2,000 joules. Find the mass of this person. Pause the video, try to solve it. Here's the answer. Your height is 10. So divided by 9.8 times 10, and then solve. These are gone. Mass equals that. Wait, what? The answer, mass equals 20 kilograms. All right, there's a quiz on the website. I'm going to do the advanced problem right now, but if you want to practice, just reminding you, there's a quiz on the website. Okay, draw this picture for me, please. Pause the video. Okay, for the advanced problem, I know that this is a 1,000 kilogram roller coaster. Your advanced problem is how much work was done to lift this thing up. So we have to go back with change in potential energy tells you how much work was done to lift it. So the motor's like click, 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 pulling it up to the top, and then it just stops, and you're like, oh. Potential energy equals work. We need to find the change in potential energy. If I know the potential energy here, call this the initial, and the potential energy here, call this the final. The difference between the two is how much potential energy changed. Okay, PE final minus PE initial equals change in PE. So, solve for potential energy at each spot, subtract it, and tell me the change. Here's your answers. This is 490,000. This is 980,000. So, 980 minus 490 equals change in potential energy equals 490 joules. If you want, you just could have said, well, how much did height change? That's how much potential energy changed. Change in height equals 50 meters. And so you just solve for that once. You can just solve for it once using this number and this mass, and that will change it. And if you know change in potential energy, you know work. There's questions on the quiz that you can use to practice with this. Good luck.